Hi. Uh, so in the last video, we discussed some details about the data, right? The column names and how the values are just simple, basic details. We also got to know the performance metric and some other details from this description section, right? So I hope you might have downloaded the data set in your local system. So if not, please do this, execute this command in your terminal or notebook. It should do the process for you. Let's understand this data in a more generic way. So by performing some EDA, right? Like analyzing this with the help of category column and some data manipulation. Okay, let's see that. So I have put my project in this Jovian platform. You can see this collection in the collections section. You can also create your account in Jovian if you have GitHub account. You can simply sign in with the GitHub account and create your notebooks there. So let me open this project. In this, I have 6 files: 00, 01, 02, 03, 04, and 05. So 00 is a file wherein the EDA is performed. Let me open this. This file is a bit larger because I have done deep EDA and visualized using Plotly, the patterns and other details. It takes some time to load. Just, yeah. This is the notebook, and this in the files part, I have the helper functions, helper classes, which I am using it in the notebook file. So the problem is that if I include all the code in the notebook itself, it becomes too large, and sometimes too much code also uh, may not be, it can make uh, it can make understanding a bit difficult, right? So I've just put this the visualizer .py, which includes the classes to visualize the data. Let's just go with the notebook and we'll discuss bit by bit. The business problem description. So we have discussed all this, right? And the problem statement, basically the classification problem. Now to solve this, to understand in a better way, there are people who have already done this project. The same links I have put here. I also referred from these links and learned a lot and implemented with their ideas also. You can also check this. These are the medium blocks and these are the research papers. You can check this in your free time. Probably you can read it. And the constraints of the problem statement is that there should be interpretability in our approach. Errors can be very costly. The main aim is to reduce the error and get the classification category. So since we are dealing with the multi-log loss, we need to get the probability of the point that it belongs to a particular category. So we'll see this everything in the code part. Now this is just the ML formulation, how we are able to, we should be solving this. Some data sources, Kaggle source and number of files, some theory about the data. And as I told you in the earlier that it has 39 classes of various crimes. And this leads to multi-class classification problem, performance metric, objectives. So all these things you can read probably in your free time, right? Please download the data and change the path if you're doing it in your local system. All right. Uh, for doing this project, we also need some other packages like GeoPandas to visualize the choropleth maps. And we also need Plotly for interactivity in our visualizations. And MPU is a package to perform some distance-based calculations. So this is the command to install all these black packages. Now these are some imports, import warnings, import JSON. So these are some package imports which I have used in the coming part. All right, then this is the file which I just showed you, where it includes all the classes with which we can visualize the data, right? So this is the modularity implementation. You can probably know more about modularity if you just Google search, and it's just very easy topic. You can probably learn easily. Now, in the data part, we have three files. Sample submission is optional, test file and train file. So we'll read this data. This is the project path wherein I have stored my data. I'm just reading the data sets, train data, test data. To visualize choropleth map, we also need police districts, basically the boundary of each police department. So I think around 10 boundary districts are there in San Francisco. Let me check. Probably I can be wrong. So yeah, there are around 10. And the names will be seen in a while. Okay, just read these data sets. Simple pandas technique to read the data. And GeoPandas to read shape files. So I have got the shape files of the three districts uh, in my local system. You can also get it from my GitHub shape files, and you can probably get the police districts shape file from this. Everything is available on GitHub. You can also check that. I'll be providing the links in the description shortly. So the shape of each train and test is that we have 87 8 lakhs 78,000 training data points, 8 lakhs 84,000 test data points. Test data is larger than train data. That does not, that should not be a problem. The first two rows of train, we have dates, category, all these columns I have already discussed. And the test, we have only 6 columns: dates, day of week, district, address, longitude, latitude. Since we do not have 2 columns that we see in train, resolution and category. Category is something that we have to predict. So this becomes our label, but we do not have resolution in our test data. So ultimately, this column does not make sense in our ML problem. We should be removing this, dropping it basically. Now let's change our column names. So we'll keep dates as time, category, description, weekday. So we have some names here. We can check it. Train columns, renaming the data, test column names, and renaming the data of the test data. Yeah. Let's remove this resolution part. So we can simply drop the columns, description, and resolution. I'm sorry, we also do not have description column in the test data. So we shall be removing that as well. And now once we remove it, we will end up having 6 columns, which are similar to test data. Cool. Now we can check the types of each column by just d types variable. So passing our data as data frame as object and using these d types pandas variable, we will get this flow type of each column. Similarly, we can do it for test. It's just for exploring the data and understanding it. Since we have time in our train and test data, we can extract some time-based features like date, year, month, day, hour. Likewise, we can extract some values, and these are actually time-based features. So we can simply pass the column and extract the year, month, day, hour, minute. Likewise, we can extract some values out of it. Since also we do not have so many columns in our data, this can be helpful in some featureization techniques, right? That's what we are doing it here. I have just made some functions that can extract all these values. From the month values, we can extract the seasons, right? So I just thought maybe we can extract the seasons as well. Doing this is because I have referred some Kaggle notebooks. If you go to code, you will find some Kaggle notebooks, which can be very much helpful to get started with the problem. So you can also go for discussions to find out in what ways the participants faced issues and how they resolved it. You can also check the discussion part there. And yeah, we can extract the season. Once we have the hour column, our value, we can also find the time period. Is it morning? Is it night, evening, afternoon? Likewise, we can get some time periods. So that's what this function is used for. It takes hour as an input and extracts the time period: morning, noon, evening, night, midnight, likewise. And apart from this, we can also extract sorry, I made a mistake. It's actually hour type, not the time period. Hour type, morning, noon, evening, night, and the time period is AM or PM. So by doing some by applying some conditions, we can easily get these values. This can be very much helpful in featureization techniques. So these are the methods or functions for time manipulation. You can go through this once I share the links in the description. Coming to text titling, if you observe carefully, what we have is we have all uppercases, be it category or police department or address. All these values are uppercase. We need to make it proper. So we can go with the text titling approach by using the method title. When we pass a string, it basically titles that text. So I'm applying some condition as part of validation and returning the title, the text. Okay. So that's about the text titling. Now, if you observe the address column, we have these short forms which are quite repetitive, be it street. ST stands for streets, AV stands for avenue. Likewise, we have so many types of addresses, address type basically. So we can extract that as well, address type. This is just a small function to extract the same. Now, if you also observe carefully that we do have this slash It simply means that it's a cross, a junction point. So we can also check for it and return the cross if it is if we have this symbol in the text, that means it's a cross. So we can return that type as well. So all these are very much helpful to featurize the data. Now once we have this, we can actually apply those methods and extract all the columns. So I'm just applying those functions which I just discussed. Uh, you know, date, year, month, day, hour, minute, season, hour type, time period, address type, and the text title. So these are the pandas way of applying. It's more optimized and more faster. We can also do it with the help of for loops, but since we have 8 lakhs of data points, it can be time consuming. So once we have this, we can write this data to a CSV, giving the path name, basically the file path, and save the whole features in a different file. And this is just a small snippet of code to validate if the features of the data already exist or not. And you can go through it. I don't think I have to go through with this because it's quite easy stuff. I've just made the function using it here by passing the train data and the test data, and writing the whole features in a CSV file. Right now, once we write everything, we can display the head train sfdf.head. So we have all these features which we got from time and address. So date, year, month, day, hour, minute, season, hour type, time period, and address. Let me zoom in a bit. Yeah. Now we also have a test, which is quite similar. So we just got these features and we just wrote in the files and reading that data and displaying it here. Now, yeah, I hope we'll continue with the next video till from here. Yeah, cool. So I'll just stop this.